Physics. I'm Akshata, your instructor, and I'm part of a wonderful nonprofit organization called KARMANT Learning. Today we will be covering topics such as speed, velocity, and acceleration, or continuation to motion. Let's get started. So today we're going to cover speed, velocity, and acceleration. Last time we went over distance and displacement, but now we're going to go over some topics that are a bit deeper. We're going to go through them one at a time. So the first thing we're going to cover is speed. Speed is the total distance traveled by an object in a certain time period. Do you guys remember distance? Well, distance is the total length traveled by an object, again, in a certain time period. Another way that we can say this is that speed is the rate that distance is traveled. So basically what I'm saying is speed is distance over time. I want to make sure you guys really know this. Speed is not a vector. It is actually a scalar. So basically a scalar does not have a direction and it only has a magnitude and a value, and it is always positive. So what is speed measured in? It's usually calculated in meters per second. So if you recall, speed is distance over time, and distance is measured in meters, and time is measured in seconds. So speed is just a value of how many meters you travel in a second. Okay, why don't we look at a practice problem? So a car travels 200 meters in 20 seconds. How fast is the car going? Okay, so when somebody asks how fast you're going, they're usually asking for your speed. So first step is to draw a diagram. So here's our car, and this is the distance that the car is going, so 200 meters. And our time is 20 seconds. Okay, so let's remember our formula from earlier. So speed is distance divided by time. Okay, so what is our distance? It is 200 meters. So 200 meters divided by 20 seconds. And this gets you a value of 10 meters per second. Okay, now we're going to move on to something really similar called velocity. Okay, so what is velocity? Velocity is the rate that displacement is traveled. Take note that it's not the rate that distance is traveled. Also notice that velocity is a vector quantity, so that means it actually has a direction, unlike speed. So it is a vector quantity because it's a rate that displacement is traveled. Recall that displacement also is a vector. So because velocity depends on displacement, that automatically means it also is a vector quantity. By now you can probably see that velocity is really similar to speed. Velocity can be calculated by finding the displacement, then dividing that by the time. The units, just like speed, would be meters per second. Another way to write this is that velocity is displacement over time. So this might look a bit confusing, so let's review what displacement is again. So displacement can be found by doing the final position of the object minus the initial position. So velocity is a vector, unlike speed, and because of this, it is common to state the direction that the velocity is acting. So we can say like southwest or northeast. Okay, so let's review what velocity is. Velocity is displacement over time. And so in other terms, it is position final minus the initial position, all over time. Also, like I said earlier, you can't forget the direction that the velocity is taking place. To make sure we really understand, let's look at a practice problem. As always, let's begin by drawing a diagram. So here we have John, and we're going to show him running 200 meters north. See how we paid careful attention to the directions. And now we're going to show John running 100 meters back towards his house, or south. This entire motion took John about 30 seconds. So our first task is to solve for the velocity. So remember, velocity is displacement over time. Let's first find the displacement. As you can tell, formulas are pretty important in physics. So let's calculate displacement. Final position minus initial position. So John's final position is 100 meters because he went down, remember? So that's 100 minus his initial position, which is a starting point or 0. So the answer to our displacement would be 100 minus 0, which is 100 meters. Now that we found our displacement, solving for the velocity should be pretty straightforward. So we have 100 meters over the time period, which is 30 seconds. If we calculate that out, we see that his velocity is 10 over 3 meters per second. Now that we've taken care of velocity, let's move on to the speed. It is relatively the same thing, except now we have distance over time. Okay, now let's calculate the distance. Remember, distance is the total length traveled. Always keep that in mind. So we have to add up everywhere that John traveled. So first he went 200 meters, then he went back 100 meters. Notice that we're just adding the distances, we're not subtracting like we did the velocity. This is because distance always has a positive magnitude. So now that we see our distance is 300 meters, so we can move on to calculate the speed. Speed is distance over time, so 300 meters divided by 30 seconds. And if we calculate that out, we can see that our answer would be 10 meters per second. Notice that the magnitude of the velocity is less than that of speed. This is because of the vector scalar relationship. Usually velocity is significantly less or equal to speed. Our final topic of the day is acceleration. I know this video is a bit long, so please feel free to pause the video and take a break. If you guys are ready, let's continue. As you can probably tell, concepts in physics are really interdependent. So acceleration is the rate at which velocity changes over time. I know we've covered a lot so far, so let's do a little review. Remember, position is the location of an object relative to the axis. Displacement is the change in position, x final minus x initial. Velocity is the rate of change of position, so x final minus x initial all over time. Finally, acceleration is the rate of change of velocity. Like velocity, acceleration is a vector quantity. This means that it has direction and a magnitude. So what is the formula for acceleration? Because acceleration is the change in velocity over time, we can see that acceleration is v final minus v initial over t. Acceleration is calculated in meters per second squared. This is kind of a weird term, but it can be written as meters per second squared or meters per second per second. So why is acceleration meters per second squared? Recall that acceleration is velocity over time, and velocity is measured in meters per second. So because acceleration is velocity over time, it means that it is meters per second divided by seconds, or meters per second squared. Unlike other quantities, whether acceleration is either negative or positive depends on the change in velocity. Let's look at an acceleration practice problem. A plane is flying at 20 meters per second when it first takes off. Over the next 20 seconds, its speed increases to 200 meters per second. What is its acceleration? So in this problem, we are given an initial velocity, a time, and a final velocity, and we are asked to find the acceleration. Based on the formulas we have for acceleration, we can see that the acceleration is velocity final minus velocity initial all over time. Our final velocity is 200 minus our initial velocity, which is 20 meters per second. And that is all divided by 20. And if we calculate that out, we can see that our acceleration is 100 divided by 20, which is 9 meters per second squared. If you enjoyed this video, please hit the like button and subscribe to our channel. Also, if you have any questions or suggestions for topics, please contact info@karmantlearning.com. Thank you for watching.